Sometimes, depending on rounding, depending on which method you take, you may get a different answer. But for this one, we get the same answer, that the whole side length is 3.8. So that means whoever has already done it, what's my perimeter?
30.4 units.
30.4 units. Again, the reason we're using a U is because they didn't tell us like inches or yards or meters or whatever. So we just have to use 30.4. Okay. Now we got all the information we need. Over there in red ink, we got the apthem. In blue ink and a little bit of green, we solved for our perimeter. So all we got to do is just plug those numbers into the formula. And I know that some of you have already done that. So what is 1/2 times 4.6 times 30.4? Let's round to the nearest. I think we've been doing 10, right, for this unit? Yeah, because we did hundredths for circles. So we're using trig, so we don't really do tenths for that. So that's cool. What is it?
69.9 units squared.
69.9, and then do not forget your units to the proper exponents. This is area, 2 dimensions, so you raise it to the 2nd power. So this is units squared. I'm going to circle it because this is a rounded answer. We rounded 3.8, and we use that rounded number to find the perimeter, so that's a rounded answer. Questions about number 24? I think once you figured out that you were given the radius, then from there it was pretty easy. We'll just do it next class. It's going to be a quiz over the area of regular polygons. We're also going to throw in some of the area of the other polygons, like rectangle, triangle, rhombus, kite, stuff like that. So that is next class. Area of regular polygons and area of the other polygons. Okay, so this is what's being projected is the formula chart. You always have access to the formula chart. I'm not a teacher that makes you memorize formulas. You have it. You'll always have it for any quiz and test. Also, if you want a copy for your home, it's been on there since day 1. It's actually been up there for the past 5 years. But if you want your own copy of this formula chart, it's on my website, the very home page up the top. You can click it, save it, print it off, wherever you want. And so these are the area formulas that are listed on there. You are quite familiar with a couple of them. First off, area equals 1/2 times base times height. That is a triangle. You've seen that. We've used it an insane amount of times in this class. And we've also solved some difficult problems using that formula. I've given you the 3 sides of an isosceles triangle, and so you drew so that the legs were pointing down and it was sitting on its base. Then you had to draw in that altitude to figure out what the height was, and so the area is 1/2 the base times that height that you have to use Pythagorean theorem to solve for. But we've used it. We're quite familiar with it. Area of a rectangle, base times height. We've seen that even in like grade school, middle school. We've dealt with areas equal to pi r squared. We've done it in this class. You've also seen it in previous classes. And then we shed some light on this 1/2 times apothem times perimeter, and doing that with the regular polygons. So these 3 is what we're going to focus on. And I know that I've already said that this is a rectangle, but also if you look over to the left, area equals area equals base times height. That's also the formula for what other shape? Parallelogram. Yeah, parallelogram. And the reason for that is like this note card, even though I cut it, it covers a certain amount of area, and I cannot create or destroy matter, so I can't make this any bigger or any smaller, even if I start moving the pieces around. So I have cut this rectangle into 2 pieces. But if I wanted to find the area of this note card, I've got my base. It's the length of this side. It's also congruent to here because a rectangle is a parallelogram. We know that opposite sides are congruent. And then this is my height. And the thing that you must remember is that for any shape at all, two-dimensional, three-dimensional, the base and the height must be perpendicular. The base and the height have to be perpendicular. And so for a rectangle, the sides, the consecutive sides, are perpendicular. So that's why we just call one side the base and the consecutive side the height, because it already is perpendicular. However, if I just move a piece of this around, it's no longer a rectangle, but these two pieces still cover the same amount of area. So if I put these two pieces together, what does this shape look like now? We don't know that.
No.
You're assuming that the sides are congruent. No. We don't know if two consecutive sides are congruent. Parallelogram. Okay, because I haven't changed the slope of the top or bottom, and since I cut along the same line, this is parallel to this side here, that's parallel to this. So all we can say is that this is a parallelogram. We can't say anything about the sides because I don't know the length of this side, and I can't say that it's congruent to this because that's a big assumption. So I don't know if this is a rhombus. I don't know what this length is or that length, so I can't say that it's a kite because we don't know if there's two pairs of unique consecutive sides that are congruent. So we just consider that this is a parallelogram. Opposite sides are parallel. However, the area is still the same. I haven't changed the area that this note card covers. And so, even if it's a parallelogram, we still use the formula. It's the base times the height. But the height that's in between my two fingers, that must be perpendicular to the base. And since opposite sides are parallel, it's going to be perpendicular to both. It's going to be perpendicular to the bottom and the top. So what we're going to see with parallelograms is that they're not going to mark the height for you. You're going to have to draw in an auxiliary segment and use trigonometry or special right triangles to find that length, because it is perpendicular to the base and it will create a right triangle that you will have to solve. Either it being a special right or we're going to have to use trigonometry. So on your notes, area of a parallelogram, I just want to make sure that you know. So this is parallelogram. Area is base times height, and then I want you to write in any shape. And I'm talking two-dimensional, three-dimensional, in any shape. The height must be perpendicular to the base. And so with this parallelogram, you're going to have to draw in that height sometimes. You're going to have to draw in that height sometimes. And when you do that, when you draw that auxiliary segment, make it so that it creates a right triangle so you can solve that using special rights or trigonometry. But I don't feel like we really need to write anything else for the area of a parallelogram. It's base times height. It's extremely similar to a rectangle. But just make sure that you're in any shape, not just parallelogram, but in any shape, the height must be perpendicular to the base. Okay, let's go on to the next one. The next one is a rhombus, correct?
Yes.
Yep, sweet. Okay, so I want you to draw a rhombus on your piece of paper. Draw it big enough so that we can draw inside of it. So this is going to be a pretty big diagram. Also, make it obvious that this rhombus is not a square. Okay, so we want to make it obvious that it's a rhombus, however, don't make it a square. we need to draw in the two diagonals of a rhombus. And then I want you to start thinking on your own, what do we know about the diagonals of a rhombus? I don't want you to yell it out right now, but I'm going to give you some time to think about it, and I want you to raise your hand and tell me some of the properties about the rhombus, about the diagonals of a rhombus. Okay. All right, so raise your hand and tell me some properties that we know about the diagonals of a rhombus. What, Bree? They are perpendicular, yes ma'am. Always. What else? Else?
They bisect each other?
They bisect each other. Please make sure that in your diagram that you are differentiating between the different marks of congruency. So we made it so that this was a rhombus. So we know by definition 4 congruent sides. And then we just said that the diagonals bisect each other. So please differentiate. These are 3 different lengths. Okay, cool. There's lots of other properties, but I did want to focus on these. Now, these 2 diagonals divide the rhombus inside, divide the rhombus into what kind of shapes?
4 right triangles.
Yeah, 4 right triangles. 4 right triangles. What can we say about those 4 right triangles?
They're all congruent.
All congruent. There are many ways, but please raise your hand and tell me one theorem that you can use to prove that these right triangles are congruent. Alice, give me one.
Side, side, side.
Side, side, side. We know that the 3 sides of all 4 of these right triangles are congruent. Give me another one. What's up, Carson?
Side angle side.
Side angle side. You got the 2 legs and then that right angle that's in between it. So side angle side. There's more. Allison, what's up?
Angle side?
Angle side. Well, with what's marked, we couldn't use that, but we do know that the diagonals bisect those opposite angles. So that is an option, but using what's marked, what else can we use? There's still one more. Hypotenuse leg. Cool. So I just wanted to blast through the past. That's going to be on your final exam. Proving triangles are congruent. Using those different theorems. So I'm just trying to remind you of this. Properties of rhombi. It's not going to go away. So good. Okay. If I told you that this was 5, and then this, we'll say this guy right here was 3. This is enough information for us to determine the area of this rhombus. Okay. One way of going about this is, let's pretend that we didn't have this formula chart. We didn't know the formula for a rhombus, and we're trying to figure this out. Well, if I needed to find the area of this entire shape, rather than not using the formula for the area of a rhombus, but how could I go about finding? How could I go about finding the area of this whole rhombus? What's up, Carson? Nick.
Finding the area of the triangle and multiplying the first 4.
Yes, sir. Thank you, Nick. So I'm going to put area, capital A for area, and then RH for rhombus is equal to, we could find the area of one of those right triangles and then just multiply that by 4. That'll give me the whole rhombus. So let's do that. Area of the rhombus is equal to area of the 4 of these triangles. I'm going to replace the area of a triangle by the formula, 1/2 times base times height, because we know the area of a triangle, 1/2 times base times height. Okay, focusing on one of those right triangles, what is its base?
3.
3. Okay? So now we need the height. So remember that the base and the height must be perpendicular. So let's say that I'm focusing on this right triangle. It doesn't matter which one you focus on. They're all congruent. We just got done saying that and proving that.